Hi, in this video I'm going to go over question 4.2.13 and it reads as follows. Use the data in the following table which lists drive-through order accuracy at popular fast food chains. Assume that orders are randomly selected from those included in the table. And we have order accurate or not accurate, and then across the top of the table the restaurants are named A, B, C, and D. So the top row represents all the accurate orders across 4 restaurants, and the bottom row is all of the not accurate orders across 4 restaurants. Column A represents the accurate orders and inaccurate orders at restaurant A. Column B is the accurate and inaccurate at restaurant B. So we have questions. If 2 orders are selected, find the probability that they are both from restaurant D. And then we have assume that the selections are made with replacement and that the events are independent for the first one. And B, assume that the selections are made without replacement and that the events are independent. So for part A, I'm finding the probability that the first is from restaurant D and the second order is also from restaurant D. When I see the word and, we learned from our notes that that means I'm going to be multiplying probabilities. So I'm going to multiply the probability that the first order is from restaurant D, and we're going to multiply that by the probability that the second order is from restaurant D. Some important words from our wording of question A. It says the selections are made with replacement. That means if I were to put all of these restaurant orders in a bag and shake up the bag and then select an order out of the bag, I would put that order back before selecting a new one. So in this case, the probability that on my first draw, I'm taking an order from restaurant D, it would be the number of restaurant D orders over the total number of orders in the table. So number of orders at restaurant D, I'm going to write at the top here, would be 136 plus 19. So that would be 155. My total number of orders is going to be the addition of all the numbers in the table. And when I add all of the orders in the table, the total I get is 1,112. So the probability that the first order is from restaurant D is going to be 155 over 1,112. I'm going to multiply that. So I got this guy here. Check. I'm going to multiply that by the probability that the second order is also from restaurant D with replacement. So that means that that first order that I took out, I'm going to put it right back in my bag, shake up the bag again, and draw again. So that means there are still 155 orders from restaurant D in my pool out of 1,112. So I'm going to multiply 1,155 over 1,112 by itself. And you can do that in your calculator. And I get 0.0194. Make sure when you put that in your calculator, you can do just like I have here, put parentheses or around each fraction, or you can put 155 times 155 close parentheses divided by 1112 times 1112, close parentheses. Make sure your calculator knows what's on the numerator and what's in the denominator. Or, since these numbers are the same, you could do 155 divided by 1112. Since it's times itself, you could just square it. Both of these ways will come up with the same thing in your calculator. So that is our answer to part A right here. The probability of getting 2 orders from restaurant D is 0.0194. We would say that these events are independent because choosing the first order does not affect the probability of the choice of the second order. So you can see they ended up being the same probabilities. Now let's look at part B. For part B, we're finding the probability that order 1 is from restaurant D and order 2 is from restaurant D without, W/O for without, replacement. Without replacement means that once we've selected order D, we're not going to put it back into our pool of choices. What does that mean? There's going to be one less order D, and there's going to be one less order in general in our overall pool. So, and, once again, signifies that we'll be multiplying 2 probabilities together. So for the first probability, the probability that our first order is from restaurant D, we'll still have 155 orders total from restaurant D, like we found up here. And just like in the first part of the problem, we still have a total of 1,112 orders to choose from. So that's the pool of orders. There's 1,112 orders total. Now, unlike in the first part of the problem, we are without replacement. So once I've selected that first order from restaurant D, it's gone. So when I'm finding the probability of selecting a second order from restaurant D, I don't have 155 orders to choose from. I have 154 orders. And because I've already selected an order, whether it was D, whether it was something else, that means there's one less total order. So instead of 1,112, I have 1,111. So now I'm multiplying 155 over 1,112 by 154 times 1,111. And you can do that in your calculator. And you will get 0.0193 when we round it to 4 decimal places. So not the same answer, but very close. And we know for this one that the events are not independent because choosing the first order affects the probability of the choice for the second order in this case. And we saw this difference when we were trying to find our second probability that we would be multiplying, 154 over 1,111. There were less orders from restaurant D in the pool, and there were less orders overall. So that's why our probability changed. I hope you found this helpful. Reach out if you have more questions.